All right. Chapter 11, Grounding. Objectives. State important grounding concepts. Explain the difference between system grounding and equipment grounding. Compare the characteristics of the grounding system of a grounded and ungrounded systems. List the primary reasons for grounding equipment. Select the appropriate size system and equipment ground conductor using the code. Identify the requirements for service grounding systems. Explain the purpose of operations of a ground fault circuit interrupter, GFI. Describe the various grounding electrode systems, their code and requirements. Size grounding electrode conductor using the code. All right. Right up here in the sauce says grounding is one of the most important facets of electrical safety for both personnel and equipment protection. In this chapter, the principles and applications of the grounding are covered in detail in Article 250, Grounding and Bonding. Address the requirements for grounding and bonding. The article is also divided into several parts. General systems grounding, Part 1. Part 2, system grounding. Part 3, grounding electrode systems, grounding electrode conductor. Part 4, enclosure, raceway, and service, cable connections. Part 5, bonding. Part 6, equipment grounding and equipment grounding. Part 7, methods of equipment grounding. Part 8, direct current systems. Part 9, instruments, meters, and relays. Part 10, grounding of systems and circuits of over 1,000 volts. When you're looking for specific code rules, first determine which part most likely contains the rules. Then find the appropriate part of Article 250 and begin your search. You can also go back into the index. If you have a keyword, look for that keyword in the grounding part and they'll tell you where to go. And then it says, safety note, grounding is as dangerous as no grounding. Improper grounding is as dangerous as no grounding. Grounding is the most important and the least understood area of the code. Become very familiar with Article 250. Then it has some definitions. This is grounding. This is a broad term referring to the intentional act of making a permanent low impedance electrical conductive path to earth. The term is used in general way to encompass the overall subject. Ground. This is the path from a circuit or the equipment to the earth. It can be an intentional or accidental. Intentional, that's when you make that green wire and you tie that green wire. Accidental is when you're touching that hot and you touch a ground, you touch a metal surface and you ground you ground yourself out. Always remember, you don't want to become that light bulb. Grounded, connections to earth through a conductor such as a driven pipe or metal plate. Grounded conductor, a circuit conductor that serves as part of the system grounding path, often called the neutral. Okay, remember the neutral is only a neutral when it's carrying the unbalanced load. Other than that, it is the grounded conductor, which is always either white or gray. Always white or gray. Equipment ground conductor, the EGC. A conductor used to connect non-current metal parts of equipment to the system grounding bus bar. The equipment grounding conductor is a part of the equipment grounding path. So that's that pigtail that ties onto the metal box. If we're running we're using the conduit as a ground, and then we got to put that pigtail in that box because we're using metal box and metal pipe to bring across to a receptacle. Remember, our ground is our first to make, last to break. So if you relying on the schools as your grounded path, well, that doesn't help you. If you remove the screws, what happens to your receptacle? Now it's ungrounded. That's why we have to put that pigtail and tie it onto the metal box if we are not pulling a green wire and we're using the metal raceway as our grounding path. Grounding electrode, a device that establishes an electrical connection to the earth. Ground electrical conductor. So that's our ground rod, our rebar, our metal plates that we put in the cement or in the ground, or our U for ground that we run around, 30 inches deep, around the house or building. Ground electrode conductor, the conductor used to connect the grounding electrode to the equipment grounding conductor. So that's our ground rod we're taking out. That's a number 6 solid, number 4 solid, or we're taking it down and laying it in the ground rod, in the concrete. Okay. Then it goes on grounding. Improper grounding is dangerous as no grounding. See Article 250. Grounding. Grounding eliminates currents from traveling through a non-current carrying components of electrical systems. See Figure 11.1. Okay, not the one on the book, but the one in your book. So when you come up here, here's our neutral, here's one hot of the transformer, here's our other hot. There's a fault. That ground goes back to earth, and it creates a low impedance path, and it should turn power off. Okay. Here's another one where we're grounded on this side. So here we have what's called a dangerous condition. So we have a fault to the metal frame, but because there is no path to ground, now all this can become energized. Our metal frame can become energized. Just as an ungrounded equipment enclosure carrying current. Dangerous condition. Current presents on equipment and metal parts. So now somebody comes, because the equipment is energized, now somebody can get electrocuted because of that fault. Okay, and then it says there are 2 types of grounding systems: a grounding and equipment grounding systems. Is a connection to circuit to the ground. Equipment ground conductor is a connection to non-current metal parts. So here's our grounding. So here's our GEC. So here's our equipment ground conductor. Here's our equipment ground conductor, I'm sorry. And this is our grounding conductor. Okay, so equipment ground conductor, that's one is going from here to there. Okay. And our grounding electrode conductor, that's the one that's coming from here down to the ground. And it says straight currents carry safely to earth. Okay, so that's our grounding. So that's when we connect all our metal parts, whether it's, here's our connection to earth, but here's our equipment ground that goes from here, which is our connection to earth. And also, this would be my grounded wire. My neutral wire. Why is it grounded? Because it's tying onto the grounding system right here. Okay, and then here's our bond to the metal frame. And then here's our equipment ground conductor that goes from here to the metal frame of this side. Okay, over here, we brought it in, and they don't have any bond to here. It just goes, they grounded the neutral out, so that's what we got to do. So now that's the grounded wire, our neutral, but there's no connection between the, so there's a fault between a hot and our metal frame. Well, that metal frame is going to become energized. Bonding. Bonding is a mechanical joining of metal parts to inform an electrical conductive path. These paths should have a little resistance as possible, and joints should be mechanically sound to prevent that gives the bonding parts continual and conductive low impedance. Oops. So here they should have showed the other pictures, but here we have our system grounding and we have our equipment grounding. That's what this picture's for. So here is our system groundings right here. So we're bringing in, here's our neutral coming off the service. Here's our neutral wire coming in. It comes to our neutral bar. Off the neutral bar, we're taking our bonding jumper to our grounding bar. And then from here, we're taking our grounding electrode conductor down to the ground rod, or metal plates, or the rebar, whatever we're using. Okay, off the neutral bar it goes off and it feeds our loads. And then now we have our ground that comes across and feeds our loads. So we're grounding off all metal non-current carrying parts. So that's what our grounding does. Again, this is our system grounding, and this down here is our equipment grounding. They should have made this green instead of a blue, instead like they have the neutral, but it comes off of here, goes across to there, makes our connection here, and it drops off to the metal frame right there and right there. Okay, our neutral comes off the neutral bar, comes off, and it feeds a load, and here's a hot, feeds that load, and here's a hot, feeds this load. But again, this is our system grounding, and then it comes off and it goes to our equipment grounding. Once it leaves our service, where our power comes into the service, okay, now there's two separate wires. They're two separate wires that do two separate things. So the bonding joins metal parts to form a conductive path. Bonding jumpers are conductors: equipment bonding jumper, main bonding jumper, and a system bonding jumper. Bond. Definition of it is Article 100. Bond means connecting or establishing electrical continuity and conductivity. Therefore, bonded basically means connecting to establish an electrical continuity and conductivity, or act of making something bonded. So going back to this picture here, this is where they're all bonded together. They all make one source. When it comes back, it's going to one source. It's either going that way or it's going down. Okay, so they're all to the same, so they're all equal right in here, but they're separate wires going somewhere else. So my bonding jumper, that's my main bonding jumper. My system bonding jumper would have a jumper going from here to my metal frame. And then our equipment bonding jumper is the one that's going to the metal frame. Bonded, we talked about that. So again, here's a better picture. So here's our neutral bar. They only got one bar, or the grounding bar and the neutral bar. We got neutral coming in, hot, hot. And then from here, we got our ground that's going off and the ground that's going off. Here's our grounding electrode. Here's our main bonding jumper that goes from the neutral to here. And then we would have an equipment ground. Here's our system bonding. So here it is here. So it's coming off the neutral bar and it's going to the metal frame. Okay, so we got grounding electrode, system bonding that's going to the metal frame here, and our main bonding jumper that's going from the neutral to the grounding bar. Okay, and that's all our connections. These are just grounds going off. The green ones are grounds going off. This black one here is the main bonding jumper. Right here you can see where it's going across, and it's going to the metal frame right there. And it's going to the conduit. It looks like it's going and connecting to the conduit right there. Okay, so that's a system bonding jumper and my main bonding jumper. Then we have our grounding electrical conductors that go off to each ones. At this point, they're all basically, you know what, you don't have to have two bars. You could have one, and they all land on the same one, as long as this is where your service is at. If this is your main panel where the service is at, then yes, you can connect them all together. Once we go to the sub panel, that will not exist. So if you have a sub panel, this bonding jumper will not exist. There is no connection between the neutral and the ground. The neutral bar would be isolated off the main panel. It says code alert: spliced unmanned jumping, unspliced manned jumping conductors, equipment ground conductors, and service disconnect enclosures to ground conductors within the enclosure for each service disconnect. Okay, so that means that unspliced main bonding jumper. Unspliced main bonding jumper connects equipment ground conductors to the service disconnect enclosure to the grounding conductor of an enclosure. So basically what it's saying is when we bring this wire up, we got to come to here, tie onto the metal frame, and then go up to here with the same conductor. Okay, where they're all tied. If you have to make a splice, it has to be an irreversible connection. You have to use an irreversible connection. All right, I'll drop it here and then I'll pick it up some other time.